Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum, good evening and hi to all the teachers, parents and the wonderful students. So welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma and selamanya percuma. Okay, before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah, and for the non-Muslim, please take a moment of silence. Okay, so before we, how is everyone doing today? So my prayer is that everyone is in the best of health and ready to proceed with today's class. Let me introduce myself first. I am Madam Rosmaya as your moderator for today and also a control host. I am a Form 6 Physics teacher at SMJKU Hua Kajang. And the most important person today is our presenter, okay, Teacher Nun. Okay, Teacher Nun. Okay, she is from College Matrikulasi Negeri Sembilan. So let us give a warm welcome to our presenter. So even though there are only two of us here, but do not worry, we will make sure that today's class session runs smoothly. So for the record, we are now live on Teacher Nun's channel. So as a sign of support to Teacher Nun for the hard work in preparing today's lesson, please subscribe her channel and not forgetting to subscribe my channel too. Okay, as usual, the lesson will last approximately 1 hour. So the certificate link and the credit claim link will be given at the end of this session. Remember that you can only use EDD email or MOE email to claim the certificate. So for credit claim, you need to collect 1 letter and 5-digit codes. I repeat, 1 letter and 5-digit codes. Which will be announced separately 3 times during our class today. So be sure to follow the class up until the end to get the complete code for the claim. Okay, I would also like to remind students to use appropriate language and also use appropriate profile picture if you wish to post comments in the chat box. So I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So please give your full cooperation in making this class a lively one. So stay focused, and if you have any questions, so you can write in the chat box and Teacher Nun will try to provide you with the answers. So before I pass this session to Teacher Nun, so I will announce the letter and the first 2-digit codes for the credit claim. Okay, so the codes are A28. Okay, A, the letter A, and the number is 28. 28. Okay, so without further ado, please welcome Teacher Nun to start her presentation.
Okay, so how's everyone? Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good evening each and every one of you. So I hope that all of you are in the good condition. So as mentioned by our moderator, Madam Rosmaya, I am Madam Nun from College Matrikulasi Negeri Sembilan. So for today's class, before we go to our revision, okay, I want to introduce you our Academy YouTuber team for the physics, for the pre-U. Okay, for the pre-U team, first we have the physics team, physics pre-U team, which is led by Madam Rosmaya. Okay, and then we also have the mathematics teams led by Teacher Im. Okay, and then for the biology pre-U team and also STPM team, led by Cikgu Faiza. Okay, for the chemistry team led by Cikgu Shahnun. And for the Perakaunan and Ekonomi Prayu team led by Madam Fizi. Okay, and the Academy YouTube also have apps you can download from the Google Play, and you can get a lot of video from these apps. Okay, now for today's class, we will do the revision and exercise for topic geometrical optic and physical optic. And the question that I will discuss is referring to the past year question for semester 2 matriculation. So you can refer to the session stated in my question. Okay, before we go to the question, I just want to highlight one important things about the equation for the mirror and lens equation. So in the geometrical optic topic, you will learn about the mirror and lens, and they share the same equation. And the important is for both mirror and lens equation, so we have the different quite different sign convention for the mirror and for the lens equation. So table 1 and table 2 shows the sign convention for both mirror and lens respectively. So during our discussion of the solution for the exercise given later on, I will, because of it is very important when we identify the hidden information, we need to know the sign for all these physical quantities such as object distance, image distance, focal length or magnification, and also for the radius of curvature. Okay, so I hope that you can remember and you know the sign convention for the mirror and for the lens equation. Okay, now we go to the question number 1. So for question number 1, a 632.8 nanometer light is incidence normally on a diffraction grating with 6,000 line per centimeter. Only the 0th, 1st and 2nd order bright fringes are observed. Explain mathematically why the 3rd order is not observed. So when I read the question, I hope that you can refer to the given information. So for example, the wavelength, the 632.8 is the wavelength of the light. And then N represents 6,000 line per centimeter. So because of that, referring to the value for N, we can determine the D, which is the separation between the slit, which is in the SI unit. Okay, and in this question, because we need to explain mathematically why the 3rd order is not observed. So our order now is referred to the third order. So N is equal to 3. So how we want to explain mathematically, meaning that we need to do the calculation, all right, to explain why we cannot observe the fringe for the 3rd order. So we refer to the equation for the path difference for the bright fringes of the diffraction grating. So which is the equation is d sin theta is equal to n lambda, and d is the separation between the slit. Okay, the given information is here. The hidden information have calculated here, and then referring to the question, we can substitute the order, which is equal to 3, the wavelength given, and we can calculate the sin theta. Because of when you calculate the sin theta, okay, you will get that the value for the sin theta, referring to the value that we have substituted, is greater than 1. What does it mean? So it is proof that the 3rd order is not observed because the maximum value for the sin theta is equal to 1. Okay, so this is the mathematically explanation why the 3rd order is not observed in this diffraction grating with the 6,000 line per centimeter. Is it clear? Meaning that you need to calculate the sin theta. And actually, if you know the equation, you can identify all the information given from the question. And then you just need to substitute in the equation and calculate the value that we do not have, such as in this case, sin theta. Okay? Alright, this is question number 1. This is actually conceptual question, but you need to explain mathematically. Okay, this is the way. You still need to show the calculation. Proof from the calculation. Okay? Please student, if you have any question, you can write down in the chat box. Okay? Alright, question number 2. A lens is made of glass with refractive index 1.6 and radius of curvature R1 is equal to 6 cm and R2 is 4 cm. An object is located 30 cm from the lens. So referring to the information given, if you take a look at the list of the information. N is equal to 1.6, R1 is 6 centimeter. I show you the plus, because of this is the hidden information. So R1 is plus 6 centimeter, R2 is plus 4 centimeter, and U is 30 centimeter. So how we identify, because I remember the sign convention for radius of curvature, it can be positive or negative. Even in the question, luckily it state R1 and R2. Why? Because of, if you want to imagine what types of lens is given to you, we refer to the position or location of the object. Okay, and then do take note that the surface near to the object referring to the first surface. So R is equal to R1 for the surface that near to the object, and then for the object which is the opposite side with the R with the radius of curvature, so the value for R is positive, and if the object is same side with the R, the sign for the radius of curvature is negative. So in this case, if you want to imagine the lens given to you, so this is the object, and do take note that R1 6 and R2 is 4. So R1 is greater than R4. Okay, radius curvature is we can imagine a circle with the radius. Let's say this is a circle represented by a radius of 6 centimeter, and this is represent the first surface. Okay, first surface which is supposed to near to the object, and the second surface supposed to be 4 centimeter radius, and then it is a second surface referring to the position of the object. So we will get the lens, okay, is this shape of lens. Okay. So excuse me. So these types of lens is called diverging or concave lens, and specific name, it is a concave meniscus. So that's the way how we identify the types of lens actually. And then another one, if you want to remember the diverging lens, the difference between the converging and diverging. So if the upper and lower part of the lens is greater size with the middle, so it is diverging. If the upper and lower part of the lens is smaller compared to the middle of the lens, so it is a converging. So that's the way how we identify either it is diverging or converging lens. Okay, so now referring to the information given, you can identify because of why both positive just now, because of, okay, as I said, because of object is opposite side with the R. See, object is here, and the radius of curvature for both circle, for both surface, is opposite side with the object. That's why both R is positive. Okay, then when we want to calculate the focal length, it is quite easy because of the clue is R1 and R2. Referring to the R1 and R2, we can use the lens maker equation to calculate the focal length. So referring to the lens maker equation, and refractive index of the material is given 1.6. The medium is normally the lens is in air because we make the lens in air, and then we substitute the value for R1 and R2. This part is quite important to identify the value, the sign for the R1 and R2. And referring to the, after you substitute, when you calculate, you will get that the focal length for this lens is negative 20 centimeter. So don't confuse if you get F is negative, because of it is correct, because our lens just now is diverging lens. So if the concave or diverging lens, the focal length supposed to be negative. Okay, so sometimes we confuse why the answer is negative, right? So it is okay for topic geometrical optic. Don't worry, because of we have the sign convention. The value can be positive or negative. The main point, you just need to match. Is it correct or not? Okay, for example, in this case, it is correct. F is negative. Okay, for question number 2, by sketching a ray diagram, we need to determine two characteristics of image. So how you want to sketch a ray diagram? So this is the diverging lens. So to sketch the ray diagram, okay, take a look here. The important for the ray diagram is the rays itself. Supposed to show the incidence ray and refracted ray, and the first ray and second ray, because of the intersection between these two rays will produce the image. Okay. So referring to the image, if you can see the yellow image here, this is our object. Okay, so the intersection between these two refracted ray. So the characteristic of image is upright, of course virtual because of this upright, diminished compared to the object, and located at the same side with the object. So even you need to determine two characteristics of image, but I just write down 4, so you can choose any 2 characteristic you can state. Okay, it's better you just write down all the characteristic also can, as long as all the characteristic is correct. Okay, so for question number 3, we go to the question number 3. A figure shows a converging lens made of material with refractive index 2.26. One of the surface of the lens is plane. Okay, this is plane, and the other has a radius of curvature of 14.5 centimeter. So determine the focal length of the lens. Okay, we want to determine the focal length of this lens. Okay, so if you look at the given information, the refractive index is 2.26. R1 is equal to infinite. Why? Because of the plane of the lens, the surface is plane surface. So the radius is infinite. And then for the radius of curvature, for the second surface is 14.5, given 14.5 centimeter. But I write down here negative. Okay, why? Okay, remember the notes here? Okay, to identify either R, the radius of curvature is negative or positive, it depends on the position of object with the radius of curvature. In this case, for the second surface, our radius of curvature is same side with the object. Okay, because of for this second surface, R is at the same side with the object. So our R is negative. Okay, because of that, this is very important because of in the question it not state either the R is negative or positive. We need to identify, okay, from your understanding. Because of we want to calculate the focal length, and also we have the R1 and R2, so we can use the lens maker equation. Actually, the equation same with the previous question, but the value for the R, I just want to stress how we identify either R is positive or negative. And luckily for this converging lens, one of the surface is plane surface. Okay, and from the calculation we get that the focal length is 11.51 centimeter, which is the positive value. It is correct because of it is a converging lens. If F is negative, meaning that it is a diverging lens. That's to prove your answer. You can means that you can check either your answer is correct or not, referring to the question 2. It is the guideline for us lah, for you. Either your answer is correct or not. Okay, so we go to the next question, which is question number 4. For question number 4, a double slit pattern is viewed on a screen 1 meter from the slit. Okay, at the same time, I hope that you can refer to the information given. So if the third order minimum are 20 centimeter apart, so M is equal to 3, which is referred to the third order, determine the ratio of the wavelength of the separation between the slit. Okay, if you refer to the information given, I write down here, the third order minimum are 20 centimeter apart. 20 centimeter apart, I write down 2 ym. So how you want to understand the question? Why the third order minimum are 20 centimeter apart, and I wrote here the information is 2 ym is equal to 20 centimeter. You're supposed to can imagine the pattern, the interference pattern that produced from this double slit. So I show you because of the third order minimum. So third order minimum, M is equal to 3 for the dark fringe because of minimum dark fringe. So 20 centimeter, meaning that the distance from the M is equal third order minimum upper side and below side. Okay, so this is the distance or the third order minimum which is separated 20 centimeter apart. That's why I write down here 2 ym is equal to 20 centimeter because of ym is the distance of fringe from the central maximum. Okay, is it clear? I hope that you understand because of this is very important hidden information. So when we get that 2 ym is equal to 20 centimeter, we have another hidden info which is ym is actually 0.1 meter only. So because of that, referring to the minimum, third order minimum equation, minimum dark fringe equation for the yang double slit. So we can use the equation for the dark fringe or minimum, and we can substitute ym, which is 0.1, m is equal to 3, okay, because of the third order, and because we want to find the ratio between the wavelength and the separation distance, so you will get the value which is equal to 2.86 times 10 power of negative 2. So do take note, there is no unit because of wavelength, and the d is same unit. Okay, so for this question, I just want to highlight the information given. Okay, Madam Rosmaya, can we take a break for a while? Because of the, sorry class, because of there is no babysitter today. My husband is outstation. I want to take a look at her for a while. Is it okay, Madam Rosmaya? Your microphone is off. Wait,
Yeah. Okay. So we go for iklan now. Okay. So before we take a break, okay, I will announce the third digit code, okay, for credit claim. Okay, so listen carefully, everyone. Okay, the digit is number 2. Okay, so the digit is number 2. Okay. So stay tuned, everyone. So watch the advertisement for the break. Okay, we advertisement now, Teacher Nun.
Okay, boleh. Okay.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, welcome back, students. Okay, Madam Nun, are you ready now?
Okay.
Your presentation.
Okay. So this is question number 1. We have calculated the ratio between the wavelength and separation between the slit. And for question number 2, we need to calculate the distance between the first order minimum and third order maximum on the screen. Okay, do take note that first order minimum and third order maximum. So there are two things, two different things. So for the solution for question number 4.2, okay, first we need to identify the first order minimum. So here, if you look at first order minimum for the dark fringe, m is equal to 1 is here, and the third order maximum, right, is here. So we want to calculate the delta x, the difference between the distance between the first and third order minimum and maximum. Okay, how? So of course, first we can calculate the first order minimum because of one minimum and one maximum. So we need to use the different equation. So you will get y1 for the first order minimum, and for the third order maximum, we use the equation of y3. So for the minimum, m plus half lambda d over d, and for the maximum, m lambda d over d. Okay, and referring to this, we can calculate the distance by minus y3 to the y1. Okay, y3 for the third order maximum, y1 is first order minimum. Okay, when we substitute the value, okay, because of lambda over d, we have calculated the ratio between the wavelength and separation distance just now, 2.86 times 10 power negative 2, d is 1. So you will get that the distance between y1 and y3, y1 minimum and y3 maximum is 4.29 times 10 power negative 2 meter. Okay, so for this question, the part that you're supposed to highlight is identify correctly minimum and maximum, because we need to use the different equation. Okay, that's the difference. Okay, the rest, to calculate the distance, it is a simple concept, but you need to identify the correct equation. Alright, so this is question number 4. And now we go to the question number 5. For question number 5, an image of 15 centimeter high is formed 24 centimeter behind the convex lens. As shown in the figure, the origin of the image is from an object of 5 centimeter high located in front of the convex lens. Calculate the object distance and also the focal length of the lens. Okay, referring to the information given, we know that you need to read carefully, identify the image distance, image height, and also the object height. And here, because of it is referring to the figure, it shows that the image is inverted. And remember the sign convention just now for the lens equation. For the inverted image, magnification supposed to be negative sign. Why we need to identify earlier? Because we can calculate the magnification as the hidden information. So magnification you can calculate using the HI per H node. Okay, when you calculate, the value is 3, but you need to put the negative because of the image is inverted. Now, this is the importance of the sign convention. Because of if you leave it 3, of course, you will get the wrong answer. Okay, and then this is considered the hidden information for the magnification. And when we want to calculate the object distance, we can use the equation for magnification, which is equal to negative V over U. Okay, why we not use this equation earlier? Because we have no value for U. Okay, we want to calculate the U, object distance. Okay, so because of that, when we substitute the magnification, which is negative 3, and negative 24 for the V divided by U, if you calculate, you will get the object distance, which is equal to 8 centimeter. Okay, and to calculate the focal length, of course, we use the lens equation. 1 over F is equal to 1 over U plus 1 over V. And in this case, if you refer to the V and our U, both is positive value. So we just substitute the positive. You will get that the focal length for this lens is positive 6 centimeter. Okay, so this is it is true for the positive focal length. It is a convex lens. Okay, that's the importance of understanding the sign convention. Okay, it help you, as I said, it help you to get the correct answer, of course. And now we go to the question number 6. For question number 6, an object placed 10 centimeter in front of curved mirror produce an image 5 centimeter behind the mirror. Okay, so object is located 10 centimeter, image is 5 centimeter behind the mirror. Okay, take a look here. If you refer to my information listed, I write down that V is negative 5 centimeter. Why? This is referred to the sign convention. If you remember, I just copy back the table here for the image distance. If you look at here, if the image is behind the mirror meaning that opposite side with the object. If in front of the mirror, meaning that same side with the object. Behind the mirror, opposite side with the object. So V is supposed to be negative. Okay, this is a sign convention for the image distance. Okay, and then we want to calculate the focal length. I think the tips is only you can identify V is negative. Okay, because of the rest is we use the mirror equation. Okay, we use the mirror equation, which is 1 over F is equal to 1 over U plus 1 over V. When you substitute, take a look here, you substitute the V, which is negative 5. So you will get that the F is equal to negative 10 centimeter, which is F is negative 10, meaning that this mirror is convex mirror. Okay? It is a lot of information that you can get from the sign convention of the physical quantity, this physical quantity. Okay? So now we go to the question, instead of we need to calculate the focal length, you also need to state the types of mirror. As I said just now, because of focal length is negative, it is a convex mirror. Okay, because of F is negative. That's the way how we identify the types of mirror after we calculate the focal length. Because of focal length can identify the types of mirror, or for the lens also it can identify the types of lens. Okay. Now we go to the question number 7. So question number 7 quite long. There are 4 questions if I'm not mistaken. So white light is incidence on a soap film of refractive index 1.33 in air. Okay, soap bubble, soap film. The reflected light look bluish because the red light of wavelength 670 nanometer is absent in the reflection. Okay, referring to the question, the refractive index of the soap is 1.33 and the wavelength of the reflected light is 670 nanometer. Absent here means missing, meaning that destructive, meaning that we cannot see the red light. Okay, so this is very important hidden information. Absent meaning that missing meaning that it is a destructive. Why it is important? Okay, so for you to understand which equation that you're supposed to choose to calculate to calculate, or if you look at the first question, the question is, does the light change phase when it reflect at air film interface? Okay, this is the conceptual question. Does the light change phase when it reflect at the air film? Air film, if you look at between the air and the soap bubble, so it is upper surface. If you can see, I write down here upper surface. So you need to explain the answer. So how you want to explain? Okay, referring to this ray diagram, this is incidence ray, incidence on the first surface or upper surface, and because of it is reflected at the upper surface, which is the denser medium, so bubble have a greater refractive index, so it will the reflected ray will have the pi radian phase change. Okay, so we can say that yes, a phase change occur because the light travel from smaller refractive index to the higher refractive index material and reflect at the boundary or at the upper surface. Okay, you can refer to the first ray. So the answer for the first, between the air and film interface, yes, there is a phase change. How about the second question? Does the light change phase when it travel in film and reflect at the film air interface? Film air interface meaning that refer to the lower surface, reflected at the lower surface between the soap bubble film with the air. Okay, film and air. So the answer is, if you look at the second ray reflected, second ray, it because it is reflect at the less dense medium, which is air, so it is 0 radian phase change, meaning that the answer is no phase change at the lower surface. Okay, referring to the ray 2. This is conceptual question that you need to answer. Okay, and then question number 373, what happened to the wavelength and frequency of light when it travel from air to the film? What happened to the wavelength and frequency? So we want to discuss between the wavelength, lambda, and the frequency when, of light when it's travel in the different medium from air to the film. So in this case, we need to refer to the equation. So the equation that we refer is V is equal to F lambda. Okay, you familiar with this equation, right? V is equal to F lambda. So referring to the equation V is equal to F lambda, we know that when the light travel in the different medium, for example, denser medium, the velocity of the light will decrease. So referring to this equation, when the velocity decrease, the wavelength will decrease because of V is directly proportional to the lambda wavelength, but the frequency is unchanged. Why? Because of still same source of light. Okay, when the light is incidence on the less dense medium, and then in the denser medium travel in the these two medium, the same light travel, so the frequency of the light is not changed. So the answer is wavelength will decrease because directly proportional to the V, and the frequency is unchanged. Okay. For question number 74, you need to determine the minimum thickness of the soap bubble or of the soap film. Minimum thickness of the soap film. So how we want to determine this T? T is referred to the thickness of the soap bubble. How minimum is the thickness of the soap bubble? So how you want to calculate? Less than minimum thickness, there is no soap bubble. The bubble is plop, pecah, right? Okay, so how we want to calculate the minimum thickness of the soap bubble? There are a few steps that you need to follow before we choose the correct equation. So the first is referring to the phase change. Okay, referring to the phase change for ray 1 and ray 2. Okay, so we can calculate the phase difference, which is because of first ray, pi radian phase change, second ray, 0 radian phase change. So phase difference is equal to pi. If the phase difference is equal to pi, meaning that the these two coherent source is antiphase. So when we identify it is antiphase, now we need to know either it is constructive or destructive, or we need to know either it is a minimum or maximum. So we know just now the clue is absent. Absent meaning that missing. If missing, meaning that it is a destructive interference. So we have two current source, antiphase and destructive. So the equation for path different is to anti, right? So the equation for path different is to anti is equal to m lambda. So this equation is for the antiphase coherent source and destructive. For the constructive, if constructive, it is equal to m plus half lambda. That's only the difference. Okay, now, because of we want to calculate the minimum thickness, what is the condition for the minimum thickness referring to this equation? So the minimum thickness is identified referring to the order. So the minimum order supposed to be will produce the minimum thickness. So in this case, because of m, the equation for the path difference is m lambda, to nt is equal to m lambda. So m is equal to 1. If m is equal to 0, there is no path difference, right? So the minimum order is 1. That's why when we want to calculate the thickness, okay, the minimum thickness, when we substitute all the value, include the n, the refractive index of the soap film, the wavelength, the order is 1. Because of that, we get the minimum thickness is equal to 2.52 times 10 power negative 7 meter. Okay, the tips is, please refer to the equation for the order. Sometimes I'm sure that after this we have another question that relate to the different equation for the film. Okay, I will explain again. So in this case, because of the equation for the path difference to nt is equal to m lambda, so the minimum thickness is when the order is minimum. In this case, m is supposed to be 1, cannot 0. Okay. So if you have any question, you can write down in the chat box. For question number 8, an object is 20 centimeter from a convex lens of focal length 12 centimeter. Calculate the image distance and magnification of the image formed by the lens. Okay, so U is 20 centimeter from the convex lens, focal length is 12 centimeter. So because of it is a convex, so F is positive. So we want to calculate the image distance and also the magnification. So it is quite clear, right? Because we have the value for U and F, we can use the thin lens equation. 1 over F is equal to 1 over U plus 1 over V. We substitute the value for F and also the value for U. You can get the V, which is equal to 30 centimeter. Okay, so this is direct. Use the lens equation. Even direct, you still need to identify the sign for the F, right? But luckily, because of F this is convex lens, so F is positive. And for the magnification, we have the value for U V. So we use the equation of M is equal to negative V over U. Substitute V 30 and U is 20. You will get that the magnification is equal to negative 1.5. Okay, once again, don't confuse with the negative answer for the magnification, because you're supposed to remember the sign convention. Magnification for the lens equation, if the M is negative, meaning that the image is inverted image. Okay, so of course, is it correct? If you want to check whether it is correct or not, or if you confuse why M is negative but you not remember the sign convention, you know that M negative is inverted image. So take a look at the V. V is positive. Positive meaning that the real image. So real and inverted is the characteristic of the image. Okay. Alright. That's the benefit of understanding the sign convention. So you will confident with your answer. Okay. Now we go to the question number 9. Okay, so for question number 9, a beam consists of two monochromatic light, 400 nanometer and 600 nanometer. So I just represent lambda 1 and lambda 2. Incidence normally on a diffraction grating which has 540 lines per millimeter. Okay, remember, if I'm not mistaken, question number 2 or 3, the diffraction grating given the line per centimeter, if I'm not mistaken. So we will see the difference. Okay. So in this question, we need to calculate the angular separation between the first order diffraction of the light. Okay, so the 540 line per millimeter is n. Okay, but this is unit millimeter, so you need to change to the SI unit, which is meter. So for the millimeter, take a look here. Length is 0.001 divided by 540. So you will get the separation between the slit in the meter unit. Okay, and then to calculate the angular separation between the first order diffraction of the light, meaning that we want to calculate delta theta, we want to calculate the angular separation between the lambda 1 and lambda 2. Okay, so what you need to do, you need to calculate both one by one, meaning that referring to the diffraction grating equation, d sin theta is equal to n lambda. Okay, we know that we need to know the theta, the angular separation. So for theta 1, okay, we just substitute the n1. First lambda is 400 nanometer. Second lambda is 600 nanometer. The rest is same because of we incidence on the same diffraction grating. So you will get that theta 1 and theta 2 is theta 1 is 12.47 degree and theta 2 18.9 degree. So when you get theta 1 and theta 2, then you can calculate the angular separation between the first order diffraction of these two light. So if you look at here, the order is 1, for both wavelength. And when we calculate, we get that the angular separation is equal to 6.43 degree. Okay, so this is also quite you need to think what you want to calculate. Not only sometimes the student is only calculate theta 1 and theta 2 because of they consider theta is the angular separation. But referring to the question want you to calculate the separation between the angular separation between the first order for both light, lambda 1 and lambda 2. Okay, sorry. Okay. For the question number 9 too, we need to calculate the highest order of diffraction that can be observed with the 600 nanometer light. So how we want to calculate the highest order? Highest order meaning that the maximum of order or maximum fringe that can be observed on the screen. So how we want to identify the highest order? Okay, so the tips or the clue is very, very important. If not, you will not get the answer. For the highest order, theta is supposed to be 90 degree. Theta is angular separation. So for each light, the angular separation is supposed to be 90 degree. So the pattern produced on the screen will be the maximum pattern. The maximum pattern will produce on the screen. Okay, if theta is equal to 90 degree. Because of that, we use the equation for the diffraction grating, which is d sin theta is equal to n lambda. Actually, same equation. We substitute, the difference is only our sin theta now is sin 90 degree. So you calculate the n order because we want to know the highest order. So in this case, the n that we get from the calculation when we substitute is 3.09. 3.09 meaning that the order is only integer, right? So n is equal to 3. Let's say if you get n is equal to 3.9. What is the n? What's supposed to be the n? Still 3. Kita tak boleh bundarkan kepada 4. We cannot forward to 4 because of the fourth order is still not performed on the screen. So n is equal to 3. Alright, please take note about that. Okay, and now we go to the question number 10. For question number 10, an object is placed in front of a concave mirror with 25 cm radius of curvature. A real image twice the size of the object is formed. Okay, take a look at the information given. Here, because I've given the radius of curvature, which is 25 cm, so hidden information is you can get the focal length of the mirror. Focal length is equal to r over 2 so equal to 12.5 centimeter. And stated it is a real image. So if the real image, of course, the image is inverted. If you want to remember, it is quite easy for me. When I'm study, I remember because this is package. Inverted, if the real image supposed to be inverted, if the virtual image it's supposed to upright. So how you want to remember? When I was studying, I remember that UV. UV is ultraviolet. So U is upright, V is virtual. So package UV or IR, infrared. Infrared refer to I, inverted, R is real. So I always remember if I want to write down the characteristic of image, either UV or IR. UV light or IR, infrared. Both is ray, right? Then I will remember real package with inverted, virtual, the package is upright. Okay. And then of course, because of this is inverted, we get the another hidden information because here it's stated that the image is twice the size of the object. So even M, we know it is equal to 2, but the image is inverted, so M supposed to be negative. Remember the sign convention? This is the very important tips. Okay, the first question, you need to sketch a ray diagram to illustrate the formation of the image because we know that this is a concave mirror. So, supposed to use the important for your ray diagram is the incidence ray. You're supposed to put the arrow for the incidence ray and reflected ray. For the first ray, which is the red light, the red ray, and the green ray, both supposed to with the arrow, with the correct arrow. Okay, so I hope that you can study the ray, the incidence ray and reflected ray for to sketch the ray diagram. Okay, so referring to this sketching, show that the position of image. Okay, make sure that you label the object and the image. Of course, when you sketch, you use the pencil, so there's no difference between the object and image, so you need to label. Okay. And then for question number 10.2, you need to determine the object distance from the mirror. So object distance is U. Okay, if you refer to the information given, we have the F, we have the M. So to calculate the object distance, first from the magnification, from the from the magnification, we substitute M is equal to -2, equal to negative V over U. And then we because of we have no value for V and also no value for U, we want to calculate the U. So here we can write down that the V is equal to 2U. Negative is cancelled for both sides. So can you see how important is the magnification? You can identify it is negative. It will give in this case, if you put the magnification is positive, so you will get V is negative. Totally wrong. Because of V is the real image. Okay. Not yet, because we want to calculate the object distance, right? So we still need to use the Till's lens equation and and not Till's mirror equation. Luckily, they share the same equation. So not Till's lens but mirror equation. So referring to the mirror equation, we substitute the F, which is 12.5 centimeter. U, we want to calculate, and V is equal to 2U. So we can calculate the U, referring to the value, and you will get the U, which is equal to 18.75 centimeter. Okay? So I'm sure that you're supposed to realize how important we identify the hidden information with the correct sign convention in the calculation. Because of the equation is easy, the equation is simple because of they share the same equation. But the concept behind the equation that you need to identify before you use each equation, before you substitute each value. Okay? And now we go to the question 11. Okay. So for there are 3 questions from this question, if I'm not mistaken. So referring to the figure shows a flint glass lens of refractive index 1.61. Okay, please refer to the diagram. Is coated with a thin layer film of magnesium fluoride of refractive index 1.38. So a ray of light of wavelength 565 nanometer is incidence at right angle to the film. Okay, so referring to the diagram, referring to the figure, you need to identify which one is the film. Okay, and in this case, of course, it mentioned it is coated with the thin layer film. So our film is the magnesium fluoride. Okay, which is with the refractive index of 1.38. So I represent here, and F refer to the refractive index of the film, because when we want to substitute later on, we will use this value. So we have 3 refractive index here, so please don't confuse. All right. And first, we need to sketch the light ray that interfere after being reflected from both surface of the film. Label the reflected ray that undergo phase change. Okay. So previously, I show you how to sketch the light ray for the thin film. So in this case, if you look at here, after you identify the film, okay, please write down the upper surface and lower surface. Why? Because remember, the incidence ray will be reflected at the upper surface and also lower surface. So how? Actually like this. Incidence ray, firstly, incidence ray incidence on the upper surface of the film, and then half of the incidence ray will be reflected as ray 1, and another half will be reflected, dipantulkan and dibiaskan, separuh-separuh. So refracted inside the thin film, and when incidence on the lower surface, it will be reflected as the ray 2. Okay, that's the situation happen. That's why we have the ray 1 and ray 2. And then how you want to label the reflected ray that undergoes phase change, you need to identify the upper surface and lower surface. Air with the upper surface, the air film, and then film with the glass. So because of both reflected on the denser medium, because of the thin film is denser, the glass is also denser medium compared to the upper medium. So both ray 1 and ray 2 will have pi radian phase change. Okay, so you need to label that both ray undergoes pi radian phase change. Okay, so this is your ray diagram for question number 1. If you want to sketch the light, so the important is you highlight the upper surface and lower surface of the thin film, so you know where your ray is supposed to be reflected and where your ray is supposed to be refract and then reflected back as the second ray. Okay, now we go to the question number 2. What minimum thickness should the magnesium fluoride film have if the reflection of the 565 nanometer light is to appear dark? Okay, actually previous question also asked about the minimum thickness, right? Okay, take a look at this part. This thin film, what is the difference? Okay, of course, because of it mentioned it is appear dark. Dark, we know it is a destructive, but we need to identify the correct equation for the path difference, right? Before we identify the correct equation, you need to identify the equation for the path difference. Okay, or the types of the two coherent source, either it is in phase or anti-phase. Okay, take a look at the phase change. Okay, referring to ray 1 and ray 2, because of both undergoes pi radian phase change. So when we calculate the phase difference, it is equal to 0. Because of pi minus pi, it is equal to 0. So because of it is equal to 0, phase difference is equal to 0. So it is two coherent source in phase. And then because of just now we identified dark referring to destructive, so the equation for the path difference is m plus half lambda for in phase but destructive. If in phase constructive, m lambda. In this case, because of it is dark destructive, so to anti, the path difference is m plus half lambda. So to get the minimum thickness, what is the condition for minimum thickness? But in the previous question, minimum thickness m is equal to 1 because of the equation for the path difference is m lambda. So how about if the equation is m plus half lambda? What is the value for the order, the m? So referring to the equation, actually it depends on the equation. Because of our equation for the path difference n plus half lambda for the destructive, so for the minimum thickness, in this case, m is equal to 0. So you cannot have file on the, you cannot remember every time for the minimum thickness m is equal to 1 or m is equal to 0. No, it is depends on the path difference equation, either m plus half lambda or m lambda. If m lambda, m is equal to 1. If m plus half lambda, m is equal to 0. Why? Because of if m is equal to 0, there is still half path difference, which is represented by half lambda. Okay, that's the reason. Okay, because of that, referring to the information given, we substitute, you will get that the minimum thickness for the magnesium fluoride is equal to 102.4 nanometer. Okay. This is tips and very important tips. So I show you two example. Luckily, two question from this past year question that showing the different application of order for the thin film. Okay, and now for question number 3, 11.3, it stated that if a lens is used to suppress the reflection of light at high frequencies, what should be done to the thickness of the film? Okay, in this case, if you read the question carefully, we want to see the relationship between the frequency and the thickness. Am I right? What happened for the high frequency? What happened to the thickness of the film? If we want to see the relationship, of course, you need to identify the equation that we're supposed to use. So in this case, because of the equation is 2nt, the path difference is equal to m plus half lambda, referring to the previous question. So we want to see the relationship between the frequencies and thickness. The thickness is here, so ask about the frequency. There is no frequency, no f in this equation, right? So we can find the relationship, which is referring to the c is equal to f lambda. We know that this wavelength is equal to c over f. So what we do, we substitute in the equation. Lambda is equal to c over f. We know that c is the speed of light, which is constant. Because of that, we get the relationship between the minimum thickness or the thickness of the film with the frequency, which is, it is inversely proportional. So, of course, you know the relationship, right? What happen if the light at the high frequencies used? What happened to the thickness? So to suppress light with the higher frequency, thickness of the film is reduced. Okay, so for the higher frequency, the minimum thickness is reduced. Okay, that's because of the relationship is inversely proportional. Okay, so this is also very good conceptual question, so that you understand even the equation for the path difference, we know either m plus half lambda or m lambda, but it also can be related with the frequency of the light. Okay, so I think that's it, Madam Rosmaya. So I thank you everyone for listening and watching with us, both of us in this class, and I hope that you all of you take care of yourself. Good luck, and don't forget to subscribe our channel, Madam Maya, and my channel. And if you can leave the very comment to this video, so I can improve my presentation and sharing next time. So that's it. I give back to Madam Maya.
Okay, so before we end our session for today, I will announce the fourth and the fifth or the last two digit codes for credit claim. Okay, so the digits are 64. 64. Okay, 64. Okay, so all of you, please stop posting your comments for a while, and if you haven't clicked the subscribe button, please do so. Make sure it turns to grey, not red color, and activate the icon bell so that you will not miss the next class session. So then if you find that the lesson was beneficial, so click like and share to your friends on your social media. Okay, spread and share the goodness. Okay, once completed, type done on the chat box before the certificate link and credit claim link are given as a token of thank you for your dedication in joining the free online class today. So I will paste the link now. Okay, the link for credit claim. Okay, another one is the cert link. Okay. Okay, so the certificate link and credit claim already given in the chat box. So please take note, the link will end half an hour after this live. So make sure to use the EDD email or MOE email only to log in. So incorrect email use will not be entertained. So if you haven't got one, so please apply. The link to apply the EDD email is given in the description below. Okay, so if you wish to get more information on the online classes, go to www.academyyoutuber.com. And to those who haven't joined EDD Junior Telegram, please do so. Okay, here with us is anak Cikgu Nun the daughter, your daughter Cikgu Nun. Okay. So once again, I would like to thank all of the students for joining today. Remember that the more classes you join, the more credit you can claim. So feel free to share this free tuition class to your friends and teachers all over Malaysia. And this is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. So thank you for being a YouTuber Academy supporter too. Okay, so I think that's all for now. See you in another session. Okay, ingat hashtag bermula percuma and selamanya percuma. Okay, Assalamualaikum. Stay safe till we meet again next week on the same day, same time on Sunday at 5 p.m. Okay, bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.